Okay, Bismillahirrahmanirrahim. Welcome to the Structural Engineering Software Application class, lecture number 8. In today's lecture, I will discuss how to model and analyze truss, wall, foundation, and staircase in SAP2000. Okay, the lecture outlines are objective of this lecture, introduction to a truss element, example on analysis of truss, then example on analysis of shear wall, then example on analysis of foundation, and example on analysis of staircase. Right at the end, class task is given for the student practice. Okay, lecture objectives. By the end of this lecture, the student will be able to model and analyze truss, wall, foundation, and staircase in SAP2000. Okay, a truss element and structure. Truss is actually the combination of frame elements, either strut or tie, which is connected through pin joint or node, and it is also called hinge, which support or resist translation motion only. In truss element, there is only member forces, either tension and compression, having no bending. Okay, in the figure, example of truss is shown, where truss element are connected to frictionless pin, right? And this is a frictionless pin at location A, B, C, and D. And keep in mind this thing: truss member are connected either in the rectangular or triangular configuration, right? And the member forces, there is only member forces in the truss elements, which is either compression or tension. So there is no bending moment in truss elements. Okay, in order to analyze a truss for member forces, there are a few assumptions given below. Okay, the truss members are connected at ends by frictionless pin, and the second assumption is the truss members are axially loaded at joints, right? The truss member will be loaded at joints only. And the third assumption is the truss members are weightless. Fine. Okay, the trusses are mainly used to model the structures such as tower, bridges, and buildings. Okay, now I will consider a truss example given below, and I will discuss the different steps involved to analyze it in SAP2000. Okay, truss can be solved in SAP2000 by following the steps given in the phase 1, phase 2, and phase 3, right? Now I will explain all three phases step by step in upcoming slides. Now phase 1. In phase 1, first and second step is to create and define grid line for the given truss example, right? For the given example, 5 grid line required in the x direction and 2 grid line required in the z direction, having 20 feet spacing each. In phase 1, step 3 is to define materials, right? For further detail about this step, please refer to lecture number 5 and 6. Okay, as per the truss analysis assumption, the truss element is weightless, so that's why in order to follow the assumption, the weight and the mass density will be put equal to 0 in the material property data, right? Okay, step 4 is to define member section. In example, 2 sections were given, section W12 class 14 and the other section. For W12 class 14 section, please refer to lecture number 6. This section can be easily imported from directory. While for the area given by 1200 mm square, add journal area. Okay, how to add journal area? Just go to define, then section properties, then frame section, and from frame section add new property section, then go to other, and from there select journal. When you just click on the journal, so this property data box will open. From this property data box, just enter cross section, which is axial area having value 1200 mm square, right? And then click on OK. So this will develop a journal area having specific dimensions, right? And the total area will be 1200 mm square. Okay, step 5 is to define a load pattern. For truss element, in load pattern, put self weight multiplier equal to 0 for dead load, because as per the assumption the truss element is weightless, so that's why the self weight multiplier will be equal to 0. Okay, for step 6 to 10 in phase 1, kindly refer to lecture number 3. Okay, step 11 is to draw a special joint, and it is additional or optional step where you can draw a special joint where required. Okay, in order to draw a special joint, just click on the special joint icon given in the side toolbar, or you can also access it by a draw menu. Okay, once you click on the draw special joint, so this property of object box will open where you can enter different coordinates in the form of offset x, y and z for the particular location where you want to draw joint. In step 12, moment are released because in truss element there is only member forces having no bending moment. In order to release moments, first of all select all members, then go to assign, then frame, then click on releases. Okay, when you click on the releases, this assign frame releases window will open. In this window, release moment 22 and moment 33 at start and at location, right? Okay, once you release moment, the truss view will change as per the diagram given in this slide. Okay, with this step phase 1 is completed. Okay, now come toward phase 2 where analysis is performed. For further detail about this phase, kindly refer to lecture number 3 or all previous lectures. Okay, now phase 3 where different analysis results are displayed. For a given example of truss, different analysis results are shown in diagram. Right? In diagram, there is a joint reaction and axial forces diagram. As I told you that there is no bending moment in the truss element, so the bending moment values are 0. Now I will solve this example step by step in SAP2000. Okay, first of all create a new model. Go to file, then click on new model and then click on grid only. Okay, as per the example, 5 grid line required in x direction, and there is no need of any grid line in y direction, and 2 grid line required in z direction, and the spacing between x and z direction grid lines are 20 and 20 feet. Okay, click on OK, right, and change the view from xy to xz plane in order to see the grid lines. Okay, the grid line are developed. Okay, once the grid line are defined, next step is to define the materials. Go to define, then click on the material, then add new material. Okay, change the name of material to truss material, right, and let's suppose the material type is steel. Okay, in the lecture I told you that the weight and the mass density will be equal to 0, so make it 0. Okay, all the other values will be as per the requirement and as per the material you choose. So I'm left the other material values as by default. So click on OK. Okay, next step is to define the cross section property. Go to define, then section property and frame section. First of all, I will import W12 class 14 section, because in the example I will giving you two cross section. One is W12 class 14 and the other area cross section is a general cross section whose magnitude is 1200 mm square. So first of all I will import W12 class 14. How? Click on the import new property, then the type of material is steel, so select I or wide flange, right, then browse the AISC file, go to local C drive, then program files, computer instructions, SAP2000. So from here AISC file, click on the AISC file and import it. Okay, once all the section are imported of W cross section, then select the W12 cross 14 section, click on OK. Okay, W12 cross 14 section is imported. Now I will define another cross section, that is the magnitude of that cross section is 1200 mm square. So first of all I will change the unit to mm, so kilonewton mm. Okay, then go to define, then section property, frame section. Okay, from here add new property, and from add new property in the frame section property type, go to other, and from other click on journal. Okay, in this journal property data, just change the cross section, that is axial cross section, to 1200 mm. Okay, so when you click on this, so a journal area will be added. Okay, change the name of the section to Truss section. Okay, and change the material to Truss material, click on OK. Okay, so both cross section are defined. Okay, next step is to define a load pattern. Click on the define, then go to a load pattern. Okay, in the load pattern, consider that all the loads are dead load. So for the dead load, change the self weight multiply from 1 to 0, because the member, as per the assumption, the truss member is having 0 weight. It is actually weightless. So change the self weight multiply from 1 to 0. So modify load pattern and click on OK. Okay, now I'm going to skip all other steps, including the defining the load cases, load combination, and other steps, because I have discussed that step many times in the previous lecture. So I'm directly going to draw the truss element. So for that, just select, just click on draw a frame or cable element. Okay, and draw your section as per. Now the structure is ready for analysis. Just go to analyze and run analysis. Okay, just click on the run analysis. Okay, analysis are completed. Now we can display different results. So first of all, we want to check the joint reactions. So for that, click on this icon and then go to joints and click on OK. So okay, this will give you the joint reaction at both support. Okay, if you want to see the different member forces at different location, so for that, just go click on this icon and go to frame and cables, right? So in this window, just click on the axial forces and click on show values on diagram, click on OK. So this will give you the axial forces to display a result in the form of table. For that, you just go to display and click on the show tables, right? Okay, from this window you can display the different result in the form of table, right? Okay, this is all about this example. Okay, now I will discuss how to analyze shear wall in SAP2000. First of all, what is shear wall? It is a vertical element designed to resist lateral forces, typically wind and seismic loads. Okay, the shear wall example is given in the figure. Okay, the thickness of this shear wall is 6 inches and the height is 12 inches and the width is 10 inches, and there is a 2-pound load applied laterally at top corner. And now I will discuss how to analyze the shear wall in SAP2000. Okay, in phase 1, the following 7 different steps are involved. For detail of all these steps, kindly refer to lecture number 3, 4 and 5 and 6, right? I have discussed all these steps many times in the previous lectures, so kindly go through the previous lecture for the following 11 steps. Okay, phase 2 is about analysis. In this phase, analysis is performed, and in phase 3, the different results are displayed. Okay, in the diagram, the different result of shear wall in the example are given in this diagram. Okay, now I will solve the shear wall example in SAP2000 step by step. Okay, first of all, create a new model and go to File, click on New Model, right, and change your unit as per given dimensions, convert into kip inches, or sorry, pound inches, and then click on the grid only. Okay, in X direction, 2 grid line required as per the given example, and there is no need of any grid line in the Y direction, and 2 grid line required in the Z direction. Okay, the spacing along X direction is 10 inches, and along Z direction the spacing is 12 inches. Okay, click on OK, right, and convert the plane from XY to XZ. Okay, this is the grid line developed. Okay, now I am going to skip all other steps like define a material property, define load pattern, load combination, and load cases, because I have discussed that step many times in the previous lectures. Just I will discuss a few steps that required in order to model a shear wall, right, and rest of all other properties I will keep by default, right. So I will just define a area section, right. For that, go to define, and then section property. From here, click on area section, and then add new section, and the name of this section is wall, and this is shell thin, and the thickness in membrane and bending is 6 inches. Okay, so the wall section is defined. Okay, next step is to draw the shear wall. Just click on the area section drawing tool and draw a shear wall. Okay, once the shear wall is drawn, then next step is to define or mesh your area. Okay, select the area element, then go to edit and divide area, and then divide your area into a different number of meshes, right. Now next step is to assign joints at the bottom. Okay, the joints are actually the fixed joint, and go select all joints, then go to assign, then joint restraint, and click on fixed, right. Now next step is to assign a joint load, and the joint load is applied at this location. So select this particular joint and then go to assign, right, then joint load, forces. Okay, the load is applied in the X direction, so enter the load in the X direction. The load magnitude is 3 pounds, sorry. Click on OK. Okay, now this shear wall is ready to run, right. Then click on this icon to run analysis. Okay, the analysis is completed. Next step is to display different results. First of all, I want to display a joint reaction. For that, click on this icon, then go to joints, and for case and combo, I want to check it for dead load, so click on OK. So this will give you the joint reactions, right. If you want to check other results in shell element, so again click on this icon, then go to shell. Okay, if you want to check the shell stresses, so for example, if you want to see the maximum value at visible faces, so click on OK, right. So this will display the stresses, the maximum stress diagram. Okay, and the values are given in the form of contours, right. Okay, this is all about shear wall example. Okay, next topic is how to analyze foundation in SAP2000. Now I will discuss that. Okay, first of all, what is foundation? Foundation is actually the lowest part of a building or stable structure, and which is in direct contact with the soil, which transfer load from the structure to the soil safely. Okay, now how to model soil in SAP 2000. This can be understood by analyzing the behavior of soil when it is loaded. Okay, in order to understand the concept of soil behavior, I will take a very simple example how the soil behave under application. Okay, let's suppose a certain magnitude of load is applied on a soil from foundation. Initially, the soil will resist the applied loads, right? And this is shown by the opposite arrow. And this resistance is actually called bearing capacity of soil. Okay, once the applied load is exceed the bearing capacity of soil, what happened? The soil will start settlement in the downward direction, right? Okay, the load or the force per unit settlement per square area is called modulus of subgrade reaction. Okay, when the applied load is removed, the soil will somehow show elastic behavior and the settlement will be recovered, but the settlement will be not completely recovered, but some portion of settlement be recovered. Okay, this behavior of soil can be modeled as a spring, right? When the load is applied on the soil, so the soil will start resisting the applied load, and once the load is further increased, so what happened? The soil will start settlement in the downward direction. Once the load is removed, so again the soil will somehow recover the settlement. So this behavior can be modeled as a spring, but this spring will be a compressive type of spring. Okay, this soil behavior is very much similar to having a spring underneath the foundation. The magnitude of spring will be the modulus of subgrade reaction, and the unit of that will be force per unit area for each unit displacement or settlement in the soil. Okay, in the table, modulus of subgrade reaction for different type of soil is given. Okay, and for the dense soil, the value is very high as compared to the loose sand and other type of soil. The modulus of subgrade reaction can be calculated by using empirical formula. Okay, and generally the Ks value is equal to 40 times the Qa, where Qa is actually the allowable bearing capacity of soil. Similarly, you can also specify the tension direction parallel to the area object local axis, or you can also specify the tension direction in the coordinate system along global x, y and z. And there is some other option where you can add, replace or delete your spring. Okay, once all the values are entered in this form, then click on OK. So the spring will be assigned to the area element. Okay, once the model is completed, next phase is to run analysis, and next phase is to display different result. In this phase you can display various kind of results. Okay, now I will model and analyze a mat foundation of single story frame structure in SAP 2000, and let's suppose that the foundation area is 1 feet more than superstructure, and the modulus of subgrade reaction for spring is 4200 kilonewton per meter square. And let's suppose the plan of this single story frame structure is 10 by 10 feet, and foundation is 1 feet more than the above superstructure, and this is elevation having 10 feet height, right? Now I will solve this example in SAP 2000. Okay, first of all, create new model, go to file, new model, and then click on grid only. Okay, initially I will develop grid lines for superstructure only, and later on I will add additional grid lines for the foundation. Okay, we require 2 grid line in x direction 2 in the y direction and 2 in the z direction, and the spacing are 10 feet, right? Okay, I will just keep all other property as by default, and I will just define the foundation. So for that, go to define, then section property, then go to area section. Okay, from there add new section, and this section is foundation, right? And then select shell thick for this area section, right? And the thickness, let's suppose the thickness of foundation is 1 feet. Okay, click on OK and OK. Foundation is full. I will draw beam and column. Okay, it will be by default. And now I will draw a slab. So for that I will change view from other view to XY. And now I will mesh the slab area element. And I will divide it into 10 points. Okay. And now I will assign joints. All the joints are hinge, so go to joint and then restraint and select hinge. Okay, now I will add additional grid line for foundation. How? Just right click and go to edit grid data and then modify and show system. Okay, at here, so I have to extend the grid line. I have to add grid line in X and Y direction, right? First of all, I will add in X direction. Okay, the next grid line will be 1 feet away from 10, so it will be 11 feet. And the third, the D grid line will be actually in the opposite direction, so it will be -1. Okay, so this grid line will be created in negative direction of X at here in this location, so I'll put -1. Similarly for the Y grid data, I will add 2 grid line, one at 11 feet and the second one will be at -1 feet. Click on OK, then OK, right? You can see the additional grid line are created for foundation, right? Now we will draw foundation for this within this grid lines. Now go to the location where you want to draw foundation. So I will move down. Now select area section, and from here section I will select foundation and I will draw a foundation at that area. Okay, once the foundation is drawn, next step is to mesh this foundation area element. For that, select this area element, then go to edit area, and that edit area as per the requirement. Let's suppose I want to divide this area into 10 points, so click on OK. So this foundation area is divided into 10 points in each side. Now next step is to assign springs. So for that, select the foundation and then go to assign, then area, then go to the area springs. Okay, first of all change your units as for the unit of spring, modulus of subgrid reaction, and that is kilonewton meter. So enter the magnitude is 1200. Okay, change the spring resistance from tension and compression to compression only, and the location of the spring is at bottom and it is inward, so rest of the value is OK. Click on OK. Now the spring are assigned at the bottom of the area as a solid. Okay, we can apply loads on the given structure, otherwise the model is ready for analysis. For example, I want to add load in this area as a area load. Okay, select the whole area, then go to assign, then area load, and I will enter any kind of load, for example 200 kip per foot. Right now I will run the analysis. Click on the run analysis and run now. Okay, once the analysis completed, you can display different result. For example, I want to check the joint reaction. Okay, this is actually the joint reaction, and these are the reaction at of the spring at different location. Similarly, if you want to check the other results, for example, if you want to see the bending moment 33, okay, similarly you can display the shell stresses, for example maximum. Okay, so the maximum stresses value will display on the slab as well as on the foundation. So this is all about analysis of foundation in SAP 2000. Okay, now analysis of staircase. What is staircase? Actually, it is a structure that connect two separate levels by a series of steps, right? In the figure, a staircase example is shown. Okay. Okay. In order to model staircase in SAP 2000, there is some templates also available in SAP 2000. So how you will access the templates? Go to new model, then templates. So the template will open. From there you will click on the staircase. Okay, in SAP 2000 there is 3 different type of staircase templates are available. Staircase type 1, 2 and spiral staircase. Okay, these are the different dimensions required for a particular type, right? And the different parameters can be checked from this parametric definition, right? So this is the area element. So if you want to change, you want to add, you want to define a new area element for the staircase, so from there you can define. Okay, so when you click on the parametric definition, so for type 2 staircase, these are the different parametric values. Okay, h is actually the height of story, and LLW is lift level width. This one LLW, and this is SPL, and this is the stair projected length, and this is the right level width, right? So LLW and RLW and SPL is shown at plane as well, and this is the elevation. Similarly, the other parameter are SW1, and it is the stair width 1, the width of stair in this location, and the next one is the OW, that is the opening between stairs. This is actually the opening between stairs, and SW2 is the stair width at this location. Okay, once you will enter all different parameters as per your requirement, so the staircase will be modeled like this. Okay, this is for the single story. So similarly, you can add for multiple story as per the space and other requirement. Okay, similarly there is a circular staircase template is also available in SAP 2000, and when you enter different parameter in this template for the spiral staircase, so this kind of circular staircase will be modeled. Okay, now I will show you how to model different staircase by using the templates available in the SAP 2000. For that, go to the file, then new model. Okay, from this this window there is a staircases template, so click on this. Okay, so there is a different type of staircase available. For example, if you choose type 2, and this is the parametric definition for this type of staircase. Okay, for example, I am keeping all these value as a by default and click on OK. Okay, this is the type 2 staircase is model. Similarly, if you want to model a circular type of staircase, so choose spiral staircase, and this is the parametric definition of staircase, right, and click on OK. So a circular type of staircase will model. Okay, now I will solve this staircase example without using templates of staircase available in SAP2000. In this example, this staircase connecting two-story building having 5 feet height, and the landing is 3 by 3 feet, and the flight is 6 feet, right? So now let's see how to model this example in SAP2000. Okay, first of all, create a new model. Go to file, new model, and change units, keep feet, click on the grid only. Okay, for the given example, we required three grid lines in each direction, 3 grid lines in X, Y, and Z direction, right? So the spacing, initially I will put any value in the spacing, and later on we can edit it. I will keep all the spacing 3 feet, click on OK. Now I will edit grid spacing, modify and show. Okay, first grid spacing at 0, and in S direction second one is 3 location, and third is at 9 location. Similarly, along Y direction the spacing is actually 3 feet, and it is also 3 feet in the example. In the Y direction the height is 5 feet, so keep it 5 feet. Click on OK. Okay, click on OK. Now grid spacing are changed accordingly. Now next step is to define slab for staircase. Go to define, then section property, area section, add new section. For example, it is staircase, and the thickness is 1 feet. Click on OK. Okay, in this example you will learn how to draw incline area member. Now select or draw poly area command and move to the first floor, right? First of all, draw the top portion, and then move to the ground floor and draw the ground floor portion. And okay, so this inclined section of the staircase is drawn. A landing section of staircase, for that again move to the first floor, and then draw rectangular area element and draw this landing section. Now I will draw another inclined section between first floor and second floor. How? Again select draw poly area and draw this first floor section, and then move to the top floor and draw this portion again. Okay, this section is again drawn, the second portion, the inclined portion, and it can be seen in 3D view, right? Now next step is to mesh your area section at different location. Select all area section, this one, and go to edit area and divide area into 10 points, right? Similarly, you can also assign support at any location, and you can also draw any beam and column in order to support the staircase. For example, there is a beam as well, so you can draw a beam at this location or any other location, right? And you can also assign joints. For example, if you want to assign joint at this location, because this portion of the staircase is connected to a wall, so go to select all these points and go to assign joints, restraint, and it is, let's suppose, a hinge connected. So this is how you can assign your joint at different location. Once the model is completed, and now you can run your analysis, and once the analysis is completed, you can display different results just like different structure. Okay, so this is all about uh, modeling and analysis of staircase in SAP 2000. Okay, now class practice task 1 and task 2. Kindly analyze these two tasks in SAP 2000 and show me result in next class. Thank you so much. This is all about lecture number 8.